Hello, another presentation by Healing Chambers International. We are America's fastest expanding freestanding hospital quality group of affiliated centers. We would like to work on science, not mythology. And as it is said there, the often heard lie is easier to believe than the seldom heard truth. Another one, Aldous Huxley. Facts do not cease to exist because they are ignored. Now here's a great one from somebody who should know better, who claims that if you wear street clothes inside a chamber, you're an accident waiting to happen. And if you happen to take those street clothes that you're wearing outside after your hyperbaric treatment and you're exposed to a flame or try to light a cigarette, this will happen to you. Whoa. Well, that photograph is a Hollywood Special Effects Department photograph. So is this science or mythology? For this to happen, oxygen would have to be a highly explosive gas. So let's talk about cotton scrubs or cotton clothing. At Healing Chambers, we provide our patients with 100% cotton scrubs. It's their choice. We prefer this. However, sometimes patients are brought from the hospital and they're wearing scrubs. Unfortunately, they're not 100% cotton. So we always check labels on patients that are brought in ambulances. We want 100% cotton. Sometimes patients have contracture deformities, and these patients find it impossible to put on scrubs. Two good examples there. So when scrubs come in, we check the label for 100% cotton, and we always make sure any pockets, and some scrubs do have them, are empty. If the patient chooses, for whatever reason, to wear cotton clothing or what is loosely called street clothing, we make sure they bring that clothing in freshly laundered. We empty all pockets, and then the patients are welcome to ride in it. Curiously, denim jeans and good quality tightly woven t-shirts double the protection time in flash fires. This was found out in a series of tests by the entertainers who do fire dancing. If you're interested in the science, go to this website here. There are a lot of rules and regulations about flammable clothing. So, is this likely to happen? No, that person is absolutely wrong. It is a common myth. It is not science. Let's go to another place. About oxygen itself. Here is another person who should really know his science. He made the statement in March 2004, just one drop of liquid oxygen in your hand can blow your arm off. Well, let's have a look. Here is a glass full polystyrene cup full of freezing liquid oxygen, pale blue in color. I selected the dirtiest part of the parking lot where the ambulances drip oil onto the blacktop and threw the liquid oxygen down on the blacktop. Wow, an instant reaction. So is that person right or is that person wrong? Is it science or is it mythology or ignorance? Let's have a look. What you're looking at there is vaporizing oxygen. Liquid oxygen turning back into gaseous oxygen. It is not smoke. Look carefully at the pattern of the oil drops in the parking lot. Now, with the last vestiges of gaseous oxygen drifting away, look at the pattern again. No evidence of explosion, no evidence of fire at all. That wasn't science, just mythology. Where did all of this begin? On a terrible day in 1967, with the Apollo 1 astronauts cramped into this tiny cockpit, a terrible accident occurred. The cockpit was full of 100% oxygen at 16.4 pounds per square inch. There was a call by the captain, fire in the cockpit. 17 seconds later, this very hot fire had taken the lives of 3 brave men. 6 months later, a congressional inquiry looked into this. It was a sealed chamber, much like a hyperbaric chamber, but now here's the interesting thing. There was extensive distribution of combustible material, lots of nylon. Even the astronauts' clothing were nylon. Vulnerable wiring carrying the spacecraft power. In fact, when the investigators came and looked, and you can see all of the wires on the bottom, some of the wires, copper and silver, had been abraded so badly with the wear and tear of the astronauts' feet that they were arcing out. And that's where an arcing fire started. When the fire started, it melted the plumbing that had a combustible coolant in it. So it was a fueled fire. There was no fire suppression system, and later on they found shoddy workmanship, poor quality assurance program, and intrinsic design flaws in that space capsule. So, the conclusion was that oxygen made the fire burn faster and brighter, but oxygen did not explode. Oxygen is simply not a flammable gas, such as acetylene. Another person who should know better, printing ink includes metal. This was in the paper. Just turning the pages of a book in a hyperbaric chamber can create a spark and cause an intense, lethal oxygen explosion. Is that science or mythology? For that to happen, oxygen would have to be able to ignite by a spark or ignite by a flame. Science or mythology? Again, somebody who should know better was wrong. Not science, just mythology. So let's unwind a really big myth about oxygen. Here's a picture of myself, Robert Elaine Sands. Over the past 30 years, I have been involved supervising well over 30,000 hyperbaric oxygen therapy treatments. It's interesting. When I show you this, we don't want you to copy this demonstration. I first performed this testing in 1984, and in April 1984 presented a paper to Duke University at the F.G. Hall Center, and it was called Combustion Experiments in Oxygen-Enriched Environment. And the professor in charge gave me a nice book after the presentation which said, "Carry on with the good work." So you don't need to do this, but we're about to demonstrate that oxygen exposed to an open flame, just as I found back in 1984, will not go bang. And this experiment is when I was working with the Australian Department of Science. And at the time we did this, we were actually full of the mythology rather than the science, and we'd even built ourselves a little safe box of sandbags in case oxygen really did explode. Taking a chamber, such as this one, and putting in a candle. With the door closed, we light the candle, and there you can see on the left-hand side the percentage of oxygen. Now, please look carefully at the candle wick. Cotton burns at a very low temperature, round about 1200 degrees centigrade. And we can actually tell the temperature of flame by looking at the color of it. That is bright yellow. So yellow is about 1000 degrees centigrade, and as we'll see, it will change. Now, also, another thing is that we're using a candle that actually made of paraffin wax melts down. When we get to 40.9% oxygen, notice what's happening to the candle flame. That candle normally takes 4 hours to burn, sitting out on a tabletop, but is starting to burn very bright and very hard. So now we've got a white yellow flame, so we can see the temperature has gone up to about 1400 degrees centigrade. But the oxygen that is now flooding into this chamber is not exploding. When we get to 100% oxygen, we're at about 1.2 atmospheres pressure in that chamber. The analyzer is not lying to you. And you can tell this because now the flame has become very white. And we know that that flame has reached about 16 to 2000 degrees centigrade. But the oxygen didn't explode. No, a flame or a spark does not make oxygen explode. For example, a spark, an electrical spark, will spark at about 13 to 1400 degrees centigrade, about what you're looking at there right now. Candles have been studied for a long time, so has oxygen. Interestingly, that candle that took hours to burn down before burned all the way to the bottom of its wick in less than 3½ minutes when it was at 100% oxygen at 1.2, 1.4 atmospheres. That terrible tragedy, what did we learn? The congressional hearing the following February, in actual fact, found that there were intrinsic design flaws in the engineering. So now, all around the world, we have different standards of engineering. For example, in America, and this is very important, we have the American Society of Mechanical Engineers, and they have a standard called pressure vessels for human occupancy. What does the society consider a pressure vessel for human occupancy? Is a pressure vessel that enclosed a human being within its pressure boundary while it is under internal or external pressure that exceeds a 2 pounds per square inch differential pressure. That is a PVHO. And every chamber you ride in should have permanently attached somewhere all of the necessary tally plate information, including this little clover leaf U stamp, which tells you that it has been carefully designed, carefully fabricated, and does not have intrinsic design flaws. When chambers do have this U clover leaf on it, the National Fire Protection Association comes in and enforces the actual chambers and the chamber environment. So when you go for a treatment with any practitioner, you should look for, somewhere on the wall or on the chamber, a sticker just like this to say that the fire marshal has come by and inspected this location and found that it is acceptable. For example, some chambers in common use today exhaust their oxygen into the room. Under the NFPA, this is totally not acceptable. It has to be exhausted outside the building. Also, there's a lot of things in chamber design with the PVHO that talks about ventilation rates in chambers. We'll come on that in just a moment. Well, what have we learned? Is this a pressure vessel for human occupancy? An inflatable chamber? Well, it certainly is. However, there are no inflatable chambers in the United States that do have the PVHO stamp on them. As simply, they are not made of the required fireproof material. These are designed to operate on room air at about 5 pounds per square inch. Do not modify this chamber, no matter what brand. Do not add an oxygen concentrator to it. Why do we say this? Well, in our experiments, and we go back to the candle flame, is if you add an oxygen concentrator, these chambers actually slowly but surely over the period of time increase in their oxygen percentage within the compartment. And we found commonly that the oxygen percentage went from the regular room air of 20.7% up to 40%. So that means if you had a fire in one of these chambers, it would burn brightly just like that candle, and you would get a fire that had increased up to the point of probably 14 to 1600 degrees Celsius. So don't modify one of these use-at-home chambers. Use it the way it is, otherwise you will be potentially in trouble. Now, more important, the National Fire Protection Association and the local fire marshal will actually close you down if you are a licensed medical practitioner and have one of these units in your office. So, yeah, very interesting is that when you go on to the biggest manufacturer of these chambers in the United States, who claim there's over 8,500 of their special little inflatable bags used safely. And they also claim, astonishingly, that the bag chambers are safer because of constant ventilation. And they also claim that, golly, static oxygen chambers are highly catastrophic potential. That is not so. And if they had taken the time to look at the standards of PVHO1, they would find that the most commonly used single-place chambers in the United States and also the multi-place chambers have very fixed ventilation rates. So, are inflatable chambers safer than pressure vessel for human occupancy chambers? No, it's about the same. This is not science. This is just sales speak. What did we learn from the Apollo tragedy? Any sealed chamber, be it a bag chamber, great caution and alert vigilance must be used. Now remember, in the Apollo, there was extensive distribution of combustible material. there was vulnerable wiring, and we're going to push this out into the use of any type of pressure vessel for human occupancy. Combustible materials must be reduced. Cotton sheets, fire retardant pillows and mattresses should be within that chamber. Clean cotton attire for the patients with empty pockets. Check, check, check. Reduce combustible materials within that chamber. Next one down, the vulnerable electricals. If a chamber is fabricated to the American Society of Mechanical Engineers PVHO1 standard, there are no vulnerable electricals there. There are very strict standards. However, it is commonly reported that a lot of people who are using at-home bag chambers to while away the time take in their cell phones or electronic games or iPads. This is a big no-no. Anything with a battery should not go in at all. What caused the Apollo fire was not a spark, according to the very important inquiry. They said it was an arc of electricity. So, a spark is about 1300 degrees Celsius. An arc is about 4000 degrees Celsius. And it is possible in a faulty communication device, cell phone, electronic games, to actually get an arc, and that arc will melt the plastic, and that plastic will set on fire at ignition point, and then we have the potential of a very fast hot fire. So, at home or in a clinic, nothing goes in there with the battery. Finally, and most important, we talked about alert vigilance. All people who operate a hyperbaric chamber must have some form of training. You should never climb in a chamber yourself and just lie there with nobody looking after you. What happens if the building catches on fire? At what point will you know if you're alone? So the chamber must never be left unattended by an exterior attendant for just a moment. Hyperbaric oxygen therapy training is actually a mandatory thing in this industry. This is what we learned from the Apollo 1 tragedy. Healing Chambers is thanking you now for taking the time to banish some of the myths, self-serving or just plain ignorance, about oxygen. If you'd like more information, go on the website www.hboinfo.com. Finally, acknowledgements. The insignias, names, quotations do not imply the endorsement of any organization or person, but especially our acknowledgement must be to the living memory of the crew of Apollo 1, Grissom, White, and Chaffee. And on their memorial plaque, they use the words, "They gave their lives in service to their country in the ongoing exploration of humankind's final frontier. Remember them not for how they died, but for those ideals for which they lived." This is Robert Lyne Sands. Again, thank you for your time.